Hi everyone, welcome to our video on mastering SAT maths with Desmos. If solving equations ever felt like a challenge, don't worry, Desmos is here to make it super simple and visual. Think of it as your math buddy that makes you solve problems faster and smarter. In this video, we'll break down the basics of solving equation, explore how Desmos can transform your approach to SAT maths. It's easy to use, fun, and trust me, a game changer for cracking tough questions. So sit back, relax, and let's dive into the world of Desmos together. Desmos is a powerful tool designed to make SAT math simpler and more visual. Let me break it down for you. First, its graphing capabilities allows you to plot equations interactively, making it easier to understand relationships and patterns. Next, it uses regression techniques, which means you can substitute values and solve equations graphically in just a few clicks, no manual solving needed. Finally, it's perfect for SAT problem solving, empowering you to tackle even complex algebraic questions efficiently. With Desmos, math becomes not just manageable, but also fun. Let's see how it works in action. Now let's dive into solving equation and isolating variables using Desmos. The first technique is the regression approach. This is a unique feature of Desmos where you replace the equal sign in an equation with a regression operator. The regression operator is this one. It is above tab key and you can use shift and above tab key for this. When you do this, Desmos instantly calculates and displays the solution for you. It's like having a shortcut to the answer without manually solving the equation. The second one is graphing solutions. Here, you graph the equation on Desmos and the solution is visually represented as the point where the graph intersects with the relevant axis or another graph. For example, if you solve equation for x, the point where the graph crosses the x-axis represents the value of x. Limitations of graphing. Finally, it's important to understand the limitations of graphing. Desmos works best when the variables in your equations are in the numerator. If a variable is stuck in the denominator, the graph might not give you meaningful or clear information. To overcome this, you may need to rearrange the equation so that all variables are in the numerator before graphing. Another important thing to understand over here is there are two types of variables. The very first is regression variables. The another one is your graphing variables. Please consider the graphing variables are only variables with x and y. These are the two variables that are being used to graph the equations, parabola, anything. When we talk about regression variables, they are all the variables from A to Z except x and y. You can also put the variables in the form of x1, x2, y1, y2 to do not put x and y. So you can replace graphing variables x and y in the equation when you're doing the regression as x1, x2 or y1, y2. This is a very important point. If you're graphing any solution, you need to put x and y as variables. If you're using regression, you need to put x1, y1, or you can use any another variable that is from A to Z except for x and y. For example, the equation is given to you that is 2p plus 7 is equivalent to 3p. Now I want to solve this particular equation. If I want to use regression, this is a perfect equation for me to solve and to use regression. Just I need to put in the Desmos that is 2p plus 7, a sign of regression and 3p. If I want to graph this particular equation, if I want to graph this particular equation, I need to replace this p with either x or y. So I can put 2x plus 7 is equivalent to 3x. That is how it works. Let's look at some of the examples for better understanding. If I'm looking at the very first example, it says what value of x is the solution of the given equation. The equation is given to me as x plus 23 is equivalent to 86. If I go to Desmos, there are two ways to solve it. Either I put the equation directly into the equation as a graphing approach, that is x plus 23 is equivalent to 86. You will see the line being plotted. You need to zoom out and you will see that the line is being plotted at x equivalent to 86. So the value of x is 63. The correct answer for x is 63. The regression approach says we need to replace the value of x, or we need to replace variable as x to something else. So for example, I'm changing this x to a. I'll do a plus 23, the sign of regression 86. The value is being displayed in this particular time over here. That is a equals to 63, just below that. I hope this is clear to everyone. Now, let's move forward to the next example. It says, what value of x satisfy the equation 3x plus 6 equivalent to 21? So I'm writing 3x plus 6 equals to 21. If you look this in the Desmos, again, the same way you can plot it. Either you write 3x plus 6 equals to 21. You will see the line is being plotted at the point of intersection with the x-axis that will give you the value of x, that is 5. So the value of x is 5. We can say x is equivalent to 5. Or you can use the regression way. In that way, you need to change the x to some another value. You can use x1 or a or b, any variable except from x and y. So I'm using 3x1 plus 6, the sign of regression equals to 21. You will see the value of x1 is 5. In this way, you can easily find the answer. So the correct answer for this particular equation is 5. Similarly, the next question is, what value of t is the solution of the equation below? You will see 2 by 7 t is equivalent to 5 by 4. This is something I need to use. The first way is to use the regression, because a variable is given as a regression variable. So I can directly use, I'll say 2 by 3 t, a sign of regression 5 by 4. It will instantly give me the value, that is t is equivalent to 1.875. Now understand one thing over here, that if the values are given in the decimal, always the values are given in decimals, in decimal. If you want to convert that value into fraction, just write t over here. It will be giving the value, and then click over here. That is 15 by 8. Correct? So you always use this toggle SND, standard to decimal conversion, which will make these values 15 by 8 or 1.875. The another way of solving this equation is by using equals to sign, or by using graphing variables. In that particular form, what you need to do, just convert this variable t to x. So I'll write 2 by 3 x is equivalent to 5 by 4. You will see the line is being plotted, that is 1.875. In this particular situation, you can again write the value, that is 1.875, and click over here to find that value again, the fraction value again. Let's explore substitution technique in Desmos for evaluating expression. These methods help solve equations quickly and efficiently. The very first is direct substitution. This is the simplest method. You directly replace the variable in the equation with its given value. For example, if the equation is y is equivalent to 2x plus 3, and you need to find y when x is 5, simply substitute x equals to 5, and it will give you into the equation, and Desmos will instantly compute the result as y equals to 13. It will happen directly. You can see, if I write y equals to 2x plus 3, and I write x equals to 5, at the intersection point, it is giving me the value of y as 13. So this value is x, and this value is y. The second one is using with keyword. This is useful when the variable appears multiple times in an equation. In Desmos, you can use the with keyword by typing something like, for example, I'm saying y is equivalent to 2x plus 3. I need to find the value when x is 5. So I'll write with x equivalent to 5. So I need to put this thing directly in one equation. It will display the answer. Let's see. If I'm writing y is equivalent to 2x plus 3 space with x equals to 5. So it will generate the result as y equals to 30 directly. Desmos automatically evaluates the equation, saving you the trouble of manually substituting x multiple times. Regression for multi-steps problems. When equation involve multi-steps or constants, you can use Desmos regression operator to combine the equation and constants in one go. For example, if solving 2x plus y equals to 10, and another equation is x minus y equals to 4. You input both equations with regression sign, 2x plus y. So definitely if you're using regression, we need to change the values of x and y to something. I'm changing x to x1 and y to y1. Two x1 plus y1, regression 10. Simultaneously, I'm writing x1 minus y1, regression 4. These techniques make substitution faster and eliminate manual efforts, ensuring precise results. Desmos takes the complexity out of the calculations and allows you to focus on understanding the problem. Now let's solve these examples for better understanding. The very first question is, if y is equivalent to 5x plus 3, what is the value of y when x is 8? Let's see. The question says y is equivalent to 5x plus 3 when x is equivalent to 8. So the very first technique is I'll write the equation directly. That is y is equivalent to 5x plus 3. The graphing with the equation is being plotted for x equals to 8. The intersection point will be my answer. That means when x is 8, the value of y is 43. So the value of y is 43. The regression way of solving is just I need to convert the variables. What I will write, y1 regression 5x1 plus 3. I just need to write x1 equals to 8. So you'll see when I write x1 equals to 8, the y1 value is 43. Third way of solving is I just use with operator. That is y is equivalent to 5x plus 3 space with x equals to 8. So you'll see 43 will be on display directly. So this shows your graphing way. This one shows your regression. And this is using the with keyword. Let's look at the second example that says if x plus 5 divided by 3 is equivalent to k and k is equivalent to 4, what is the value of x? I can use the regression directly. As I can say, I'm changing the value of x to something different. For example, I took x as a over here. I'm using regression. It says a plus 5 divided by 3, a sign of regression. And I directly need to use for the value k equals to 4. So I'm putting this value k directly into the equation over here with a sign of regression. 4. It will give me the value of a as 7. It is faster and very quick. You can also use the graphical way by writing the same equation, that x plus 5 divided by 3 is equivalent to 4. I'm directly putting the value. You will see the value is 7. This is how you can use these techniques. By using Desmos, you can quickly substitute values and solve such problems without the need of excessive manual calculations, making your problem solving faster and more efficient. Now let's look into techniques for solving and evaluating expressions using Desmos. The very first is using regression. Regression is a powerful feature in Desmos that helps you solve for a variable and evaluate expressions efficiently. For example, if you need to solve 4x plus 6 equivalent to 18, we just learned, we just simply replace the sign to regression and change the value of x to some another variable except for x and y. So my new equation can be of the form 4a plus 6 regression sign 18. And I just plug this value inside of the Desmos. Desmos will instantly calculate and display the solution for a. This eliminates the need of manual algebraic steps, as you have already seen this. Second is the graphical approach. Desmos allows you to graph equation and visualize their solutions. Once you have graphed an equation, you can manually substitute the solution values into the expression for verification. For instance, if I'm graphing y is equivalent to 2x plus 3 and finding where it intersects a specific line or point can help you substitute those values back into the equation to check your solution. The third is handling approximation. Desmos is also useful for converting decimals into fraction, which can be particularly handy with precise answers as required. For example, if a solution is x equivalent to 3.333, and you can use Desmos to convert it into fraction, the fraction value for this particular decimal is 10 by 3. Let's see on the Desmos. I have already given you the glimpse. Let's see. If the value is 3.333, you just need to click over here. You will see the answer is 333 divided by 1000. If you write 10 by 3, the same value will be there. These methods make solving expression faster and more reliable, reducing the chances of errors and giving you confidence in your answers. Let's look at some examples. The very first question says, if 4a plus b is equivalent to 9, we need to find the value of a plus b. Let's see. You can also look forward for the options as all values are in fractions or either integers. So we need to work in accordance with that. As the variables are in the regression variables, we'll using the regression directly. So for a plus b, a sign of regression equals to 9. The value of a turns out to be 2.25 and b is 0. I need to find the value of a plus b. So I'll write directly a plus b. It is giving me 2.25. I'll click on this particular sign for the fraction value, that is 9 by 4. So I can say the value of a plus b is 9 by 4. I can easily see that 9 by 4, option number A, is the correct answer. Let's move forward to the second question. It says if 2, 4t minus 5 plus 3t is equivalent to 50 plus 5t, what is the value of 8t? Again, the variable given over here, t, is in the regression form, is a regression variable. So we'll use regression for quick calculations and no for no confusions. So this is 2, 4t minus 5 plus 3t, a sign of regression, 50 plus 5t. You will see the value of t is being displayed as 10. But the question is asking me to find the value of 8t. So nothing I need to do. I just need to type 8t. The answer is 80. I hope this is clear. Let's look forward for the next question, which says if 4x plus 6 is equivalent to 10, what is the value of 8x plus 12? Now, in this case, the variables are graphing variables. So if I need to use the regression, I need to change this x to something else. For example, I normally use x as a. Let's see. You can go either ways. We'll use both the methods. Let's see. First of all, I'm using graphing. 4x plus 6 is equivalent to 10. The value of x is 1. For 8x plus 12, the value is 20. Let's see how we can use the regression feature. I'm writing 4a plus 6, a sign of regression equivalent to 10. The value of a turns out to be 1. I need to find the value of 8x plus 12. So I'll write 8a plus 12, 8a plus 12. So it will write the answer directly, that is 20. So you can use either regression or graphical way. Let's move forward for the fourth question. It says if 9x minus 4 is equivalent to 8, x minus 4 plus 36, what is the value of x minus 4? So there are two ways to do this particular question. You can easily see that x minus 4 is behaving as a variable in the equation itself. Either you replace x minus 4 with something else. Like for example, I consider let x minus 4 is a. So the new equation formed can be written as 9a is equivalent to 8a plus 36. And I just need to solve this equation by using regression for the value of a. I got the same answer. Or I can use regression directly over here to find the value of x and then subtract 4 from it. Or you can use the graphical way. All three ways are possible. Let's see. So first of all, I'm using the regression way. This method. I'm writing 9. Again, the variable is graphic, so I need to change it. I'm making it a. A minus 4, a sign of regression, 8, a minus 4 plus 36. It will generate a value of a as 40, but I need the value of x minus 4. That means I need to put a minus 4. So when I put a minus 4, my answer is 36. Or I can use my second method, which is quite quick. I can write, I'm just changing the value of a to something different. For example, a1 and both the variables. So let's see. 9 a1 is equivalent to 8. Sorry, the sign of regression, 8 a1 plus 36. My answer will be very direct. It is 36. The third is I can use the graphing way where I need to write the equation directly, which is written in red. 9 x minus 4 is equivalent to 8 x minus 4 plus 36. You will see the line is being plotted at this particular point, which shows the value of x as 40. I need the value x minus 4. So I'll write x minus 4. You will see the intersecting point is at 36. So 36 at 40, the function value is 36. So your answer will be 36. I hope this is clear. Now let's discuss how Desmos helps in combining like terms to simplify SAT math problems. The very first is regression simplification. Desmos automatically simplifies equation by combining like terms when you use the regression operator. For example, if an equation is given to you 3x plus 2x plus 5, a sign of regression equivalent to 15. This is the equation. I need to solve it. So Desmos will automatically understand that this is 5x plus 5, a sign of regression 15, and solve for x instantaneously. This saves you from manual combining terms and reduces errors. The second one is graphing for clarity. When you have equations with multiple terms, graphing them in Desmos provide a visual representation of their solutions. For instance, if you input y is equivalent to 2x plus 3 plus x into Desmos, and it will display a simplified graph of y is equivalent to 3x plus 3. You can then use the graph to identify solution points visually. The third one is algebraic transformation. If you manually combine like terms, Desmos allows you to verify your work by inputting the transformed equations. For example, if you simplify 4x minus 2x plus 10 to 2x plus 10, it will definitely give you the same graph. Let's see all three examples one by one. So we have three examples. This is example number one, regression simplification. This is example number two, and this is example number three. I'm looking forward for the very first case. This says, I'm using regression. Definitely, I'm changing x to a. I cannot use graphing variables for regression variables. So I'm writing 3a plus 2a plus 5, a sign of regression 15. As it generates the result a equals to 2. For a similar case, if I write 5x plus 5, a sign of regression 15 also generates the same result, that is a equals to 2. Correct? Now let's look forward for the second example. In the graphing case, you will see it simplifies the graph. That is y is equivalent to 2x plus 3 plus x. You see a red line which intersects at 0, 3, and minus 1, 0 with y-axis and x-axis respectively. The same line will be plotted when you write y is equivalent to 3x plus 3. A blue line shows the same graph. You can hide the line from here and you can see whenever needed. The third example says 4x minus 2x plus 10. Now this line intersects at points 0, 10 as y-intercept and minus 5, 0 as x-intercept. A similar graph can be plotted as a simplified version, that is 2x plus 10. So see the purple line, which is the second line, will show that, and the same points are being reflected. By using Desmos for combining like terms, you streamline your calculations, ensure accuracy, and gain a clearer understanding of the equation. This is especially useful for SAT problems where time and precision are crucial. Let's work on some of the examples for better understanding. I'm using the graphical method for the very first example and the regression method for the second one. The first equation says 1 by 3 times x plus 2 is equivalent to 5 minus x. What value of x satisfies the equation above? Let's find the value of x. So I'll write the equation directly. 1 by 3 times x plus 2 is equivalent to 5 minus x. You will see the value is 2.25. I can write the value 0.25 to find the fraction of it, that is 9/4. Let's understand how regression helps. The second equation says 7p plus 2 plus 6p minus 3 is equivalent to 13p. In this case, I have the regression variable, so I use regression. What value of p is the solution of the equation above? Let's find the value of p directly. So I'll use the regression this time. That is 7p plus 2 plus 6p minus 3, a sign of regression 13p. You will see the value of p is 0. The value of p is 0. Let's discuss how to handle equations with unknown values in denominator using Desmos. These equations come with unique challenges, but Desmos provide efficient solutions. First of all, let's understand graphing limitations. When a variable is in the denominator, the graph often becomes undefined at certain points, preventing meaningful coordinate displays. For example, in the equation 1 by x plus 2 equals to 0, the graph will show a vertical estome where x is equals to 0, making it difficult to identify solutions. So definitely we know if I'm writing 1 by x plus 2 equals to 0, I definitely know the value of 1 by 0 is not defined or infinite, so it do not show the graph at that particular place. Taking the value of x to the numerator is very crucial and important. That is the first part. Regression as a solution to bypass graphing limitations, use the regression operation in Desmos. It will allow Desmos to solve the equation directly, providing accurate results without relying on the graph. Third, equation manipulation. Rearrange equations. A practical solution is to rearrange the equation so that variables are no longer in the denominator. For example, I'm writing 1 by x equals to 2. Multiply through by x to get 2x equals to 1. In this way, the variable in the denominator is sorted. You can input this manipulated equation into Desmos to find solution easily. You can also see an example displayed in front of you, an equation given where a graphical approach is being done, 1 by x plus 2 divided by x minus 2 equals to 0. It is showing you the result equivalent to this, 0.6667 for the value of x. You can also write by transforming this value to this side, that is 1 by x is equivalent to negative of 2 by x minus 2, which also generate the similar result. You can flip the variables to write something like this. X divided by 1 is equivalent to negative of x minus 2 by 2, which also gives you the same result. You can also use the regression, that is 1 by x1. I'm using x1 at the place of x, as x is not the regression variable, it's a graphing variable. So for regression, I need to use x1 plus 2 divided by x1 minus 2, a sign of regression 0. That will generate the value of x1 as 0.6667, which is more or less the same. And to figure it out, what is the fraction value? I just write x1, which displays 2 by 3. By using these techniques, you can solve complex equations involving denominators efficiently and accurately, whether through direct regression or by manipulating the equation to work around graphical challenges. Let's solve this example. It says 1 by y is equal minus 3 divided by y plus 3 is equivalent to 0. What value of y satisfies the equation above? I can use the regression directly, or I can use the graphical way. So let's graph this. If I'm writing 1 divided by y minus 3 divided by y plus 3, which is equivalent to 0, you will say the value of y is not being given. I'm not able to see the value of y at this point, right? So that is the limitation of a Desmos that I'm trying to say. If you want to compute the value of y, you need to distort this equation. I'm writing the whole equation again. You can copy paste also by Control C, Control V. It works in the Desmos. And the sign of equals to. You will see that you're not able to figure it out the value at this point again. That is again a limitation of a Desmos. So we need to use the regression or we need to take the variables into the numerator. The best way is to flip the whole equation. I can write y is equivalent to y plus 3 divided by 3. Now we'll see in this case, the black line is showing the value that is 1.5. I can write 1.5, that is 3 by 2. Or you can use regression directly. I'm using a at the place of y and doing the regression. The equals to sign will change to the sign of regression. You will see the value of a is 1.5 displayed. And just you need to find the value of a in the fraction form. You just write a and click over here. That is 3 by 2. So that is the limitation. I elaborate one more time. These two equations as denominator in as the variables are in the denominators is a limitation. Graph do not show the results. If you take the variables into the numerator, definitely you will have the value of y when it crosses the y-axis. You have the result that is 3 by 2. Or you can use the regression. I hope this is clear. To conclude our session on mastering SAT math with Desmos, let's recap its key benefits. Simplify complex problems. Desmos simplified even the trickiest equation with its regression and graphing tools. It streamlines the problem-solving process, letting you focus on understanding rather than getting bogged down in lengthy calculations. Visual learning. Graphing equation and Desmos make abstract mathematical concepts tangible. You can literally see how equations behave, which makes it easier to grasp the relationship between the variables. Efficient and accurate. By automating calculation and minimizing human error, Desmos ensures both efficiency and precision. This is crucial for SAT prep, where time and accuracy can make all the difference. Desmos is more than just a tool, it's a game changer for your SAT math preparation. Use it to build confidence, save time, and solve problems smarter, not harder. Thank you for following along, and I hope Desmos becomes your go to companion for mastering math. Best of luck for your SAT prep.